Today I am going to demonstrate how to build a production-ready GenAI application using the RAG framework. RAG stands for Retrieval Augmented Generation. It is immensely powerful framework to curb hallucination in LLMs and impart domain-specific knowledge from external sources to LLMs. To build a RAG application, there are two key aspects. First, building an ingestion pipeline to fetch data from variety of sources and parse it, chunk it, generate embeddings on top of it, and finally ingest into the vector database. And second, building an application UI which takes input query from users and then actually uses the vector database to answer the questions along with LLM that was having its data written by the step 1. We will also see how an administrator can configure these applications. They can also publish it to the users and monitor all the responses. What you are seeing is the Gathr Web Studio, the central control pane to create, manage your ETL or AI pipelines. As you understand that to create a RAG application, first of all, we need to ingest data to vector database. We have created one such pipeline. Let me open it. In this pipeline, what you are seeing is a canvas where you can drag and drop multiple components from the palette that you see on the right side. You can see that we have variety of sources. You can read data from real-time source or the batch source, be it semi-structured or structured data. Once you have read the data, then you can transform the data using the transformation components. Suppose you are reading the data from S3 binary file and next you want to convert it into binary text, then you can use PDF parser to fetch the text out of it. Once you have transformed the data, then you can also use the analytics sections, components. We can leverage AI ML operator that provide integration with LLM platforms like OpenAI, Azure OpenAI, Bedrock, and these integrations can be used to text generation, image interpretation, multilingual text processing, embedding generation. Finally, once you have analyzed your data, then you can write it to the databases. These are the components that helps in emit data. In our use case, we are using the Pinecone vector database. We are currently supporting it and working to make integration with Redis, Melvis, etc. So all these components in this palette will be served as a building block for creating your AI ML pipeline. Let's walk through what we have done in this pipeline for this use case. These are the two flows. We have observed that people are trying to capture a lot of information from the data that they already have on their website. And one way to get that information is through sitemap. What we have done in this use case is we are reading data from S3 where sitemap is uploaded and then extracting URL, scraping and chunking text information out of it. And then finally you will get all the data from these URLs in small chunks. That is it there in the first flow. Another way in which people are capturing their data is in PDF files that they already have. This flow is about reading data from PDF file that is kept on the S3 and finally fetching the small chunks out of those content and further processing it in this pipeline. Now let's have a look at the detail of this pipeline. So in S3 source, in the first flow, we are reading data from sitemap.xml. We can see that sitemap file has been read, but what we are interested is in URLs. The next transformation will help us in fetching all the URLs. Now we need to scrap data from these URLs and chunk them into small sections. We have written a custom Python code that does that. It scraps the data and chunk it. You can create your operator out of it and reuse it multiple times. We have used fixed length strategy to create chunks of 28,000 characters and 200 characters overlap character count among pages extracted. You can change as per your use case to create the chunk strategy by using strengthens words, paragraphs, or any other splitting strategies. Then you can convert this data into the formatted output using the JSON parser. This has ID, text, and URL. Text is the content that is fetched from the URLs that was chunked. And URL is the unique address to that particular page from where this chunk is extracted. And ID is unique column. Now let's go to the second flow. We are reading files that are kept at S3 location in binary format, and we can have so many such files so that we can read incrementally. You can see that base 64 encoded string is going to get read over here. Once we have the binary information, Then we are going to convert it into meaningful information using the PDF parser. Let's have a look at the configuration here. First, we are going to select the column that is present. We can also parse the password protected file and even extract the images to support the multimodal RAG applications. In order to split the content, you can split the content in page, section, lines, or words. And you can have a unique identifier, page number, or any other. Here, if a PDF has, let's say, 10 pages, then page number 1 to 10 will be extracted out of it. And the content is going to get chunked in the content column. Let's have a look at the data. You can see that data has come in the content column and unique identifier is available in the section column with the page number 1 to whatever the content is in the PDF. Once we have this content, we want to unify the flow format, which is same as the above flow. So we have used the SQL transformation for that. Both the flows have ID, URL, and text column. ID is unique identifier and text is the content. Now let's unify both the flows using the union transformation. Now we are generating embeddings. Embedding are numerical representation of your data. Here we are using OpenAI operator for embedding. We could have used Bedrock, Azure OpenAI for embedding. In fact, using Python operator, you can bring in your any other model to generate embedding as well. Let's have a look at the configuration. We are using the embedding model text embedding ADA002 and the output column will be embeddings for the input text. Let's have a look at the data. We can see that embeddings have been generated. It's an array of float. Once we have this information, then we can configure our emitter. Let's have a look at the configurations. In order to create the connection, we provide the API key and the region. Then we select the index. For us, it is Gathr doc embedding. You can create your own. Then we select the embedding column, which has the vectors and the unique identifier column ID. You can auto-generate it as well. The text and URL information are also written on Pinecone so that later on we can refer back the information on which this current vector is generated. We write the data in Pinecone in two modes, overwrite or upsert. Currently, we are writing in overwrite mode. Now let's save and run the pipeline. Once the pipeline runs, then we'll see how this data looks on the Pinecone. We can see that pipeline has run successfully. Now let's go and have a look at the Pinecone console, how this data looks. We can see that data has been written in Gathr doc embedding index on the Pinecone console, and we have all the information like text, URL, and embeddings over there. Now next we'll see how this information is going to help us in our RAG-based framework of the chatbot. But before that, we are done with writing the data into our vector database. Now let's build RAG-powered chatbot referring to this vector database. There are two applications, admin application, user application. Admin application is where RAG details are filled as an admin. For example, Pinecone DB connection, prompt, OpenAI connection details, which endpoint to use, which LLM to use while building the RAG. Then the user application, where user can ask questions and get answers. First, let me show what end user will experience. As you can see here, a welcome message is there and few suggested questions are also available. The name of the company is here and the name of the assistant is here. You also have a disclaimer message and a banner here. Now let's try out some questions. We are going to ask a question that how can I connect to Salesforce using the Gathr? Here, it responds with detailed step to connect with Salesforce based on the information ingested in the vector database. Now let me ask another question, that is how to run a pipeline in Gathr. We can see that it has given answer of how to run a pipeline in Gathr from the vector database that we have stored. This is how a user will experience. Now we can go to the administrator configuration to see how an administrator will see this app. This is administrator's view. There are a couple of sections available here. One is create new chatbot section, then all chatbot sections that you have created, and then the test chatbot that you are going to create. In the general settings, Here you provide the details of the chatbot name and the questions and rest of the configuration. What LLM model to be used while generating the embeddings or generating the final answer has to be inserted here, and which vector database do we have to connect to answer the questions. I have already created one Gathr assistant for us. In interest of time, we'll look into the configurations that are available there. You can reconfigure those configurations by clicking on configure. You can see here that in the general configurations, we have entered the couple of questions. These questions will be visible on the UI for the user's view. Then there is a threshold time of 20 seconds. If we are unable to answer in that time, then this error message will be shown. The disclaimer message will be shown at the very end of the user's view. We can change the company name or the assistant name along with the left side banner text here. Then let us have a look at the LLM model configurations. Here you can select the model. We have selected the text embedding ADA002, and the model that is used for the AI answer generation is GPT-4 1106 preview. Here we enter the OpenAI key and the system prompt. Let's have a look at the system prompt message. The prompt is, you are a support assistant for ETL tool called Gathr and Gathr internal policy documents. User will ask questions about Gathr feature and how to use them. This is the prompt which will be used by OpenAI, and along with it will also send vector database curated information to fetch the answer from the OpenAI. And if it doesn't get the answer, then we are also asking it to say that apologize, I do not know the answer. Now let's go back to the configuration section. In the vector DB section, we'll provide the Pinecone environment details, GCP starter and its API key. And then we also mention the index name in the index name section. In the top K, we tell how many top answers would be picked from the vector DB. In the context and source, we tell what are the metadata sections that contains the content and the source link. Once we submit this, we are good to configure, and now we can publish this as well. Before publish, we can also test it. When we click on the test, we can ask questions here itself and get the answers. For now, we have already seen how the questions are getting answered on the user view, so we'll not see that. Let's publish this. While publishing, we can see that we select the roles, be it admin or the user roles. For now, we have set all the users role here. Once you publish this, then we are good to have this link to be used by all the users in the organization to use this chatbot. Admin can also track the insights as each questions are being recorded. This is the dashboard where admin can understand and evaluate how the chatbot is working. The average response time, how many questions have been answered successfully, what are the likes, dislikes, and all the questions here. This is how it works in the nutshell. OpenAI embedding model will first generate the embeddings for the questions that is asked, and then top 3 results are searched matching that vector query. Then the vector will have associated text that will be again going to OpenAI model with system prompt, and we finally get the relevant answers. All right, to summarize what we have covered in this session, with Gathr, you get the building block to build the AI ETL pipelines and out of the box application to build, manage, monitor your application. The beauty of the solution is we are easily able to configure end-to-end RAG application, and we can easily keep our vector DB updated automatically by scheduling ingestion pipelines along with its UI being generated with low code, no code Gathr SaaS application. I hope this session was helpful. Thank you.